Hello everyone, this is a tutorial about how to run path analysis in SEM using AMOS software. Let's see some theoretical background of SEM, and this structural equation modeling is multivariate statistical analysis technique that is used to analyze structural relationships. This technique is the combination of factor analysis and multiple regression analysis, and it is used to analyze the structural relationship between measured variables and the latent constructs. In my last video, I have already discussed how to run the confirmatory factor analysis. Today, in this video, we will see how we can run the path analysis. Now, before developing the model for path analysis, we should know the rectangles will be used to represent the observed variables or the manifest variables. The error terms or the disturbance term will be shown by the circle, small circle. Covariances will be shown by double-headed arrows, and the regression or the directional path will be shown by the single-headed arrow. Now, this is an example of simple path analysis model where we have two x1 and x2. These two are the independent variables, whereas x1 is the dependent variable. So in this model, if we see the double-headed arrow, which is going from x1 and x2, they represent the covariances. D will represent the error terms. Single-headed arrows, they show the impact, like what is the impact of x1 on y. Y is the dependent variable, x1 is the independent variable. What is the impact of x2 on y? Again, x2 is independent variable, whereas y is the dependent variable. Now let's see with the example, another example which says there are four factors, f1, factor 2, factor 3, factor 4, which have some impact on the factor 5 with some error term. Now, in our theory or in the conceptual model, if we assume that there are some factors that are independent factors but have some impact on some dependent factor, how we can find out what is the level of impact? Is the impact significant or not? Like we do some hypothesis, and for hypothesis testing we can utilize the results of path analysis. And another example which is shown by the covariances. So we have two options. We can find out the impact of these factors directly on the dependent variable without covariances among the independent variables, or we can also assume that what is the impact, individual impact of all these factors on the dependent variable if these independent factors they have covariances among them. Now, for this analysis, I'll be using a dummy file and a dummy model which shows that there are four dependent variables which have some impact on the product purchase, like packaging, availability, price of the product, and familiarity with the product. But we have to find out what is the impact of packaging on the product purchase and how much is the impact. Is the impact significant or not? Similarly, if we want to find out what is the impact of availability of the product on the product purchase, price, and familiarity on the product purchase, without having any correlations among these independent variables, we can make our model in this way. Or we can assume that there exist some covariances among and correlations among these independent variables, and then what is the impact on the product purchase. Now to do this analysis, we will go to the AMOS software. Once you will open it, this page will be in front of you. You can change the interface. I like to work in the landscape mode because it provides more space for making your model. You start with taking the file wherever you have saved this file. Let's take an example of 4 factors. You select the 4-factor data file. It is saved by this name. You open it. OK. Now all the variables of these 4 factors are shown here. 1, 2, 3, 4, and 5th one, which is the dependent variable. Now to make this path analysis, factor 5 is dependent variable, factor 1, factor 2, factor 3, and factor 4. These are the 4 factors. We will drag it here. Then what we will do, we'll try to resize them. We can change their positions like this, and now we want to make some arrows which shows what is the impact of factor 1 on factor 5, what is the impact of factor 2 on factor 5, factor 3 on factor 5, and factor 4 on this. Now this is a simple model. You can do some touch-ups. This is a very simple model, very basic model and hypothetical model, which shows that we are expecting some relationship, some impact of these factors on factor 5. Now go to analyze, and we want only standardized estimates because we are not making any correlations here, so we cannot get the squared multiple correlations or other things. So we will take only standardized estimates and minimization history. Close this. You have to save. Let's say test 1. I saved it. You run this model. It will say you have not correlated all the independent variables. We will say yes, proceed with the analysis because we want to run it in this way. There is some error, it is showing. Let's check what's the error. Yes. Now one thing more I want to tell you in this, whenever we have the endogenous variable, this is endogenous variable. Endogenous variables are those variables where we should have some error terms. And how you will find out whether it is endogenous or exogenous variables? Here we have factors, all these factors, these are exogenous variables. These are exogenous variables. So exogenous variables will not have any error terms. These are also called the independent variables or the exogenous variables, where only the arrows are going out from the rectangles. The endogenous variable are those variables where the arrows are coming in and they can also go out. If we have the mediation effect, if we want to find out the mediation effect, that is a more complex form of models that we can see in the coming videos. They will have an error term. So we forgot to put the error terms. Once we put the error terms, again we save it. Now if we run, again it will ask, it is saying that you have not correlated all these variables. We'll say yes, I don't want, and you have the results. You have unstandardized estimates and the standardized estimates here. Now this is one example for checking the impact. Now when we say standardized estimates, these standardized estimates will give the impact of these factors on factor 5. Let's take the example of the product purchase. We will select the file product purchase, and you can view the data from here, whether you have selected the correct file for developing your model or not. Yes, these are all the variables here, data view. Now you will click OK, and then again product purchase is the dependent variable. We have packaging, availability, price and familiarity as the independent variables. We'll go to plugins. You can select resize variables. You can rearrange the model as you want, like this, and we will make the arrows like this: price, familiarity. We'll select all, touch, like this. We'll have error term, we will rename variable here and go to analyze, standardize estimates and square multiple correlations. We'll tick mark, we save test 2 and we will run. It will ask, you have not correlated, we don't want. So it is showing that the impact of exogenous variables on the endogenous variable. Here in this case we have exogenous variables are the independent variables. We have here in this model packaging, availability of the product, price and familiarity. These are all independent variables, or we can say these are exogenous variable in our model. And the endogenous variable, we have product purchase. This is also called dependent variable. So this model we have developed without the correlations among the exogenous variable. Now we would like to draw some covariances among the independent variable. We'll touch up these variable, click here. After that again, now we can calculate the squared multiple correlations because we have drawn the double-headed arrows for all the independent variables. Now you close this. In this calculate, we are not clicking on modification indices as and residual movements, as we are not going for the model fit. Now we can click run. We have the output. When you click the output, after making double-headed arrows or covariances, we will get the data for covariance as well and correlations both. So when you click the standardized estimates, the single-headed arrows, they will tell you about the impact of these independent variables on the dependent variable. Like, what is the impact of packaging? It is 0.51, availability 0.54, price is negatively having impact on the product purchase, familiarity 0.44, and this value 0.97 is R square value. These are correlations among all these independent variables. When you click the unstandardized estimates, it will tell you more data. These are unstandardized values. Here you will find the variance, and these are covariances. These are variances on the top, and you can check this also by clicking the data file here. Go to estimates. This is very important file, and we will see how we can interpret it, and the detailed interpretation I'll be doing it in a separate video, but just we will see what are the important things that we should see after getting the results. P-value talks about the significance level. The triple stars, it will tell, if you click here you will find that it is talking about the details. It is highly significant. So we can say the impact of packaging on product purchase, it is significant, which means 1 unit increase in the packaging will have 0.336 unit positive impact on the product purchase. Similarly, we have the positive impact and significant, positive and significant impact on the availability on product purchase. We have negative significant impact of price on the product purchase, and we have positive significant impact of familiarity on the product purchase. These are unstandardized coefficient or partial coefficients. These are unstandardized coefficient. If you go back to the model, the unstandardized value, these values are 0.34, 0.38, all these values are here. 0.34, it is rounding off the third digit, third, so it becomes 0.34, 0.38, 0.08 and 0.28 in the model. Here it is 0.28. So now we can go to view text, and in the view text it will open here. Go to estimates, click, and you will find that this is the most important output that you have to quote after running the model. This estimate standardized regression weights, these are standardized regression weights. You can interpret this table same like the multiple regression table, that what is the impact of packaging on product purchase, availability, price and familiarity. And down you will find the R square value, squared multiple correlations. This is R square value. Now if you go to the model, in the model, in unstandardized estimates, these are covariances, and in the text you will find covariances. These are all the values of covariances mentioned here. Then these are variances, 0.31, 0.28 and so on. Variance will be here down. This is all the variance, all are significant. And covariances, all the values are given here. Some are significant, some are insignificant. correlations. When you go to standardized estimates, these are covariances, correlations. This value, all these values are from here. Okay, so R square I have already told, it is in the last. So in this way we do our structural equation modeling in AMOS, and we do path analysis. This video was mainly concentrated on the estimates, or you can say on finding out only the impact of the independent variables on the dependent variable. What is the impact? You can find the impact without the correlations among the independent variable. You can also find the impact by making the correlations among all the independent variables. That's all. Thank you for watching.